Here we want to find the limit as the function as x to goes to infinity. And the first function is given as cosh of x, or hyperbolic of cosine. So the first step, we write the definition of the function, which is e to the x plus e to the negative x over 2. And now what we can do is take the limit, and then we're gonna write the function again. Now what we want to do first, we will factor the half out of the limit. And now we can take the limit, but before we can take the limit, we have the term e to the negative x can be written as 1 over e to the x. Now we are ready to take the limit, so as x goes to infinity, the fraction here, 1 over e to the infinity, this will go the same as 1 over infinity, and this term gonna go to 0. Why? Because imagine that we have a fixed numerator and the denominator is increasing in value. The fraction gonna go to 0, and then what we left off is 1 over 2 e infinity, and this is actually the same term as 1 over 2 e to the x. And here's why. So as x goes to infinity, the cosh function here gonna behave the same as what's in the red line, which is the function half ex. That's why the answer is half e to the x. Now for part 2, we have sinh of 2x over cosh of 3x. So first we start writing the definitions of both. So the definition of sinh, as you see, and we're gonna write the definition of cosh. Now we have for sinh, x is 2x, so we're gonna block x as 2x, so gonna be e2x minus e to the negative of 2x over 2. And for cosh, we have x equal to 3x. Therefore, the term gonna be cosh over 3x gonna be e 3x minus e to the negative 3x over 2. Now, these two terms are divided by each other, so this is what we are going to do. I'm gonna write the top term. I'm gonna substitute for each by its definition. And now what we can see is we can simplify this term by moving the 2's at the denominator, and went up with this with these terms. So now we are ready to take the limits. The limit as x goes to infinity of sinh of 2x cosh of 3x is the same as e2x minus e to the negative 2x over e3x plus e to the negative 3x, which written as, so I wrote the fraction in term of 1 over the e. So this can be easier when x goes to infinity. So this is the same as 1 over infinity, and 1 over infinity is just 0. So went up as e2 infinity over e3 theta. And what we notice here at the bottom, will grow faster because of the 3. Therefore, this is be the same as 1 over the infinity, which is 0. Therefore, the limit as x goes to infinity of sinh of 2x over cosh of 3x gonna be equal to 0. Now part 3, we have this function and we want to find the limit as x goes to infinity. So again, we started by writing the definition of sinh of x, and then here x is 2x. So that's gonna be e to 2x minus e to negative 2x and all over 2. Now we're gonna write that term, so e to 2x from the given, and then we're gonna substitute sinh of 2x, what we just found. And then now we can simplify this term by writing it in this way. So we will flip the bottom fraction, so we'll bring it up. Now this is equal to 2e to the 2x over e to x minus e to the negative 2x. So now what we need to do is we want to take the limit as x goes to infinity. And we're going to substitute for that given function by the value we just found, by the term we just found. So I factor the 2 out of the limit term, and we'll end up with these terms. Now I'm gonna flip the e, so we get rid of the negative 2x from the negative sign. Now I'm just like x as goes to infinity, and notice here this fraction 1 over e to infinity is the same as 1 over infinity, which is just goes to 0. Now we'll end up 2 and then e to 2 infinity over e to the 2 of infinity. And this is their same terms, therefore, yeah, the value is going to be 1 and the limit will be 2. So this is the limit as e of 2x. So limit as x goes to 0 of e to the 2x, then over sinh of x, of 2x. For part 4, we have this function which we want to find what is the limit as x goes to infinity. So again, we start with the definitions of sinh and cosh. Here sinh is x equal to x squared. So what we're gonna do, write that in terms of x squared. So ex squared minus e to the negative x squared over 2. And then the same thing for cosh of x squared, it's gonna be ex squared plus e to negative x squared and over 2. Now what I'm gonna do, I'm gonna divide the terms. So I'm gonna substitute what we just found. Now we can simplify, so the 2's will go, and e to the x squared minus e to the x squared, and the same thing for the top, but it's gonna be with positive sign between the e's. Now what I'm gonna do, these e to the negative, I'm gonna write them in I'm gonna rewrite them in fraction form. So I'm just writing these in fraction form. That's what I'm doing in here. Now we are ready to find the limit as x goes to infinity. So this is the given function. And we'll plug that value, so the limit as x goes to infinity of what we just found, which is ex squared minus 1 over ex squared, and then over ex squared plus 1 over ex squared. Now we're gonna plug as x goes to infinity, so we're gonna e to infinity squared minus 1 over e infinity squared over e infinity squared plus 1 over e infinity squared. So remember, 1 over e infinity squared is the same as 1 over e to infinity, which is the same as 1 over infinity, which will go to 0. So this fraction will go to 0. I'll end up with e to infinity squared and e to infinity squared. These terms are the same, therefore the limit value will be 1. Now here we have this function cosh 2x over sinh over 3x, and we want to find the limit as x goes to infinity. So again, we'll start with the definitions of the limit. We write these in terms of the e. Now what I'm gonna do after finding cosh 2x and sinh 3x, I'm gonna divide these and try to simplify these. This is the cosh 2x function. Now this is the sinh 3x function. The 2's will go together and we'll end up by e 2x and then plus e to the negative 2x over e to 3x negative e negative 3x. Now what I'm gonna do, I'm gonna write these in fraction form. So it's gonna be first one 1 over e to the x, and the bottom term gonna be 1 over e to 3x. Now we are ready to use the limit. So the limit as x goes to infinity of what we are given, which we can substitute by e terms Now we are ready to evaluate that as x goes to infinity. And now remember, 1 over e to 2 infinity is the same as 1 over e infinity, which will go to 0. So the fraction will go to 0 and down by e to 2 infinity over e to 2 to 3 infinity. So what we notice here, this is infinity is multiplied by 3. It's gonna grow faster than the top, which multiplied just by 2. Therefore, this is the same as 1 over infinity, and the resulting will be 0.